everyone, welcome back to my channel. This is my first video of my first playlist of Theory of Computation. Firstly, let me introduce myself. Myself Saloni Chathani, currently pursuing Master of Computer Applications from International Institute of Professional Studies, DAVV Indore. In this video, we are going to solve the first question of Theory of Computation. Here we go. The first part of first question is given notations of representation the following component of formal language. The answer of this question is, in this question we have given some component of formal languages and we have to tell the notations of the components in the way they are represented. So the solution is the alphabet is denoted by sigma. The next one is string. So the string is denoted by capital W. The next one is empty string. The empty string is denoted by the upper arrow. The next one is the length of the string. The length of the string is denoted by the mod of capital W. The next one is prefix and suffix. Prefix and suffix are denoted by small t. The next one is language. So the language is denoted by capital L. The next one is operators on language. The operators on language are represented by union, intersection, concatenation, etc. So that's all for this question. Now we will move forward to the next question. So the second part of the first question is define FA acceptance of string by FA. So the solution of this question is finite automata. Finite automata is phi tuple. That is round braces Q, sigma, this symbol Q0 and F, where Q is the finite set states. Q equals to curly braces Q0, Q1, Q2, Q3, Q4. Sigma is the finite set of input alphabets. So sigma equals to curly braces 0, 1. Q0 is the input state and this symbol is the set of transition function. F is the accepting states final. So the acceptance of a string by a finite automation refers to whether the finite automaton, when given a specific input string, ends up in an accepting state after processing the entire string according to its transition rules. If the automation reaches an accepting state, it is said to accept the string, otherwise it rejects it. So the acceptance of rejection of a string by a finite automaton depends on whether the final state it reaches is one of the designated accepting states. So that's all for this question. Now we will move forward to the third part of the first question, that is give four difference between NFA and DFA. NFA means non-deterministic finite automation and DFA means deterministic finite automation. So firstly we will see DFA. So in DFA, dead configuration is not allowed, while in NFA, dead configuration is allowed. In DFA, multiple choices are not available corresponding to an input, while in NFA, multiple choices are available corresponding to an input. In DFA, upper arrow move is not allowed, while in NFA, upper arrow move is allowed. In DFA, designing and understanding is difficult, while in NFA, designing and understanding is easy. That's all for this question. Now we will move forward to the fourth part of the first question, that is state true or false. In this question, we have given some sentences and we have to tell whether it is true or it is false. So here are some sentences. The first one is, if L is the language accepted by NFA-M, then L is also accepted by DFA. So the answer is true. Yes, if L is the language accepted by NFA-M, then L is also accepted by DFA. The next one is, for every NFA, there exists an equivalent DFA that simulates the behavior of NFA. So the answer is true. Yes, for every NFA, there exists an equivalent DFA that simulates the behavior of NFA. The next one is, in NFA to DFA conversion for N state NFA, there exist of most to n state in DFA. So the answer of this is false. No, in DFA to NFA conversion for n state NFA, there exist at most 2n state in DFA is not possible. So that's all for this video. Thank you so much for watching my video. If you really like this video, do subscribe to my channel and do comment on this video. Thank you so much for watching.